Hey everyone, we are in your classwork here. Looks a little bit different at the top than what yours does. It is your lesson 17 classwork packet though, all right? Once we get here, it should look the same. You should have those same pictures that we're dealing with here. So what they're asking us to figure out here if the scale drawing is a reduction or an enlargement of the actual picture. So we're gonna start with the actual picture. All right. And if we notice here to get to the scale drawing, it has gotten larger. So we are talking about an enlargement. All right. If we go on below here and we look at the actual picture that we are dealing with, there's your actual. You can see here we have gotten smaller. We are dealing with a reduction. So there you go, people. That's all that it takes from that standpoint. Let's get into the better stuff here. All right, let's get to the better stuff next page here. So they're asking us to use the graph provided to decide if the rectangular cakes are scale drawings of each other. Okay, so we do need to plot some points first. So let's see here. We've got the ordered pair 5, 2. So I'm going to go to the right 5 and up 2. Doink. We're going to put a spot there. All right. I've got the ordered pair 5, 5. So I'm going to go to the right 5, up 5. Boom. There's another one. The ordered pair 11, 2. So I'm going to go to the right to 11 and then up 2. All right. And then the last one there for cake 1 is to the right 11 and up 5. So we've got ourselves a nice little rectangle that's working here. All right. Okay. Cake number 2, we're going to go to the right 1, but then we're going to go up 6. So to the right 1 and then up 6. So let's see what happens here. To the right 1 and then up 6. So that would be right there. I'm going to go to the right 1 and then I'm going to go up 12. 10, 11, 12. Dink. Ooh, up. How about that? There we go. And then to the right 13. 10, 11, 12, 13. Then all the way up to 12. All right. Make sure I'm lined up here. Okay. Right about there. And then 13, 6. So I'm going to go to the right 13. All right. And I'm going to go up 6. So there we go. If I go ahead. Ooh, not the smoothness that's there. That's okay. That's all right there. So use the graph provided to decide if the rectangular cakes are scale drawings. Okay. So they're not just asking if it's an enlargement. Okay. They're not asking if it's some sort of reduction. They want to know if they're actual scale drawings. Now, I know they will be scale drawings if they end up being proportional. All right. So the lengths of the original drawing. So typically when we talk about a length, that's kind of like the height. Width typically goes left to right. So like the main thing is it doesn't make a difference. All right. So the original drawing that was there. So that will be the first one, which is cake number 1. All right. So that's cake number 1. All right. So that's this guy right there. So the length of it there. So I'm going, again, we're going from the bottom of it to the top. I know it's a little bit thicker, but if we go and count, the 1, 2, 3, I could count. The other thing I could end up noticing is looking at all the y coordinates. And I say the y coordinates because it's going up and down just like your y axis that's there. And if I notice, I'm going from a 2 to a 5, a 2 to a 5, which makes sense that before I said it had a length of 3, so that just verifies it. I'm going to look at the width that's over here. I guess I interpret that they're lengths of the drawing. I guess they mean the length and the width that's there. All right. So from there, I can count 1, 2, 3, 4, 5, 6. It looks like it's a 6 that's there. But what I'm going to go back is I'm going to check my coordinates that are there. And because I'm going left to right, that means I'm like my x-axis. So I'm going from a 5 to an 11. Yeah, that does make 6. So we're good there. All right, the second drawing that we are looking at here. So here I'm talking about the length that's there. So I'm going up and down. So I'm going from a 6 up to a 12. All right. So that should give me a 6 that's there. I can count 1, 2, 3, 4, 5, 6. I think I'm all right. Let me go back up and check. Let's see what's going on here. So I'm going up and down like the y coordinates, like the y-axis. So to get from a 6 to a 12, yeah, that would end up being 6. Okay, so I feel good about that. And then the width there, so I'm going from left to right. So I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think it's a 12. But again, I can use my x coordinates because it looks like my x axis. And yeah, let's see here. I'm going from a 1 to a 13. Yeah, that is a 12. All right, so I feel good about what we got going on here. So are the pair of corresponding links proportional? All right. Okay, yes, they are. And we're going back to the same old idea here. Yes, they are. And that's because there is a, you know where I'm going at here? You know what word I'm going with here? All right, all right. Yeah, we ourselves are constant. We're multiplying by the same thing that's here. So there's a few different ways I could go about this. Is I could be like, hey, look, we're multiplying to get from the 3 to the 6, the 6 to 12. We're multiplying by 2 each time. We could also do the whole y over x thing. The 6 on top of the 3, that would give me a 2. The 12 divided by 6, that would also give me a 2. So I'm going to have that same constant. So simply saying the word out is fine. Obviously, if you want to do that y divided by x, we can definitely do that. So is there a constant proportionality? All right. What is it? Okay, so here's the thing. We do have to worry about the order of events. And so for a lot of times students get kind of, they're like, well, wait a second. So am I going to do the 3 over the 6, the 6 over the 12? Should I do the 6 on top of the 3? Like, what's the order? The best thing of looking at this is what's going on here. Did your picture get bigger? Well, yeah, cake one. Yeah, there's cake one. Yes, it did get bigger. So let's think about it, people. What can you multiply to get something bigger? Are you going to multiply something by half? Yeah, no, because that would mean dividing it by 2. So yeah, that tells me, hey, that constant is going to be a 2 in here. All right. Because again, it got bigger, and that's what you want to get caught up in there is because it got bigger, my constant needs to be bigger than 1. Because if you multiply by someone who is smaller than 1, yeah, it's going to make it smaller. Because remember, multiplying by a fraction is the same thing as dividing that's there. So would this image be considered a scale drawing? Does the constant work every single time? Yes, it does. So yes, all right, because again, we've got ourselves that same constant that we have dealing with. So let's come on back up here and take a look. Again, when we go from the lengths, constant of 2. When we go from the widths, constant of 2 each time. So yes, we are using that constant. So then is it a reduction or enlargement? Well, like we talked about, it got bigger, so it has to be an enlargement. And the thing that we're after here is the fact that our constant was bigger than 1. So yes, so those are, again, that's one of the key things we're taking away from it here is don't always worry about order. Just clear your head here, people. If you're saying the constant is bigger than 1, it's getting bigger. It means it's an enlargement. That's what we want to take away from it. All right, guys, you guys are done. Yes.